Hello everybody, so I'm here to do the marking of the exam autumn half term 2 week 2. So I'm going to write my start time and then I'm going to write my end time at the end. Start time is 5:22 and obviously I'll do my end time when I finish. So this exam starts off I think quite easily with some simple recall stuff. These are just testing whether you know the functions of components of blood, and if you don't know them, it's something you've got to go and self-quiz on. Make sure that you do know them for when GCSEs come around, because it could be some easy marks in the bag. White blood cells destroy microorganisms. A microorganism is a type, or could be a type of pathogen. Pathogens also contain or also include viruses and bacteria. Red blood cells carry oxygen around the body, and platelets help to clot blood. So that's one mark for each of them that you've got correct. Moving down, one waste product that is transported by the blood plasma. I think the best way to think of this is to consider what actually happens in your cells. So respiration happens in the cells. Everybody should be familiar with the word equation for this one. So glucose plus oxygen changes into, I'll just do this quickly, H2O plus CO2, and then obviously releasing energy. So blood is delivering glucose and oxygen to your cells, and then water and carbon dioxide are being removed from the cells because they're the product. The energy is being released and used. I think the most obvious one for a waste product would be to write CO2, carbon dioxide, because we breathe that out. We don't need carbon dioxide for any of our metabolic reactions that happen in the body. Okay, let's move on. Should have done that one in green pen, but there you go. So the way to remember this is that blood vessels which take blood away are arteries, and that blood vessels that take blood back, I like to say into the heart, they would be veins, because we've got the IN in there. And I'll just switch over to my green pen like I should do. Arteries away from the heart and veins back into the heart. Okay, give yourself a subtotal out of 6 for everything that we've done so far. Here's our diagram of the heart. We should be really familiar with this. Label your heart nicely. Remember that you need to swap over left and right. Obviously this is normally left, this is normally right, so we'd write right on this side, left on this side. Atriums, or atria, which is the plural, are at the top. Ventricles are at the bottom, because A goes before V in the alphabet. You know A is on top. Therefore A is going to be your, nearly did my blue again, right atrium, so it's singular, right atrium, it's meant to be an A there, and B is going to be your right ventricle. Okay, a mark for each of them. Moving on, the function of blood vessel C. So you should be familiar with the way that blood moves around. It comes back from the body down the atrium, the right atrium, through the right ventricle, and back up here to the lungs. It collects oxygen whilst it's at the lungs, comes back into this atrium, the ventricle, back up there, and then the aorta takes the blood to the body. So what's the function of C? There's blood coming in to the heart from here. Okay, starts off going round there, boom, 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 up towards the lungs. So lungs here, round, back into the heart. The blood is now oxygenated because it's come from the lungs, and then it can take that oxygen to the body up here. So what should we write? It is taking blood from the lung to the heart, because it's come from the lungs to the heart, and that's C. So tick that one. Okay, moving on. Coronary heart disease. Now, it develops when layers of fat build up on coronary arteries. You should be familiar with this treatment. It's a stent. It's put into a coronary artery. It expands the width of the coronary artery, and that allows blood to more easily flow through because there's more space. You can see the fatty deposits here. I'll just shade them in blue to make it really clear. They are narrowing the coronary artery here. There's less space for blood to travel through, but here they've been widened by this wire mesh, and there's now more space for the blood to travel through. Heart attack is caused when heart muscle cannot respire. If we look back to that equation that we wrote before, we know that we need glucose and oxygen for respiration, and that's what we need to write in here. Glucose, oxygen. Okay, we've got a slightly longer question coming up here, but if you just think about what you know, it shouldn't prove too much of a problem. The first thing you need to say is that the stent keeps the coronary artery open, right? That's the function of a stent. I'll just do it as bullet points for now. Stent keeps the coronary artery open. Right? That isn't given to you in the question. Obviously you've got a diagram here which shows that, but you still need to know that that is what's actually happening in the diagram. So you'll get a mark for writing that. Your second mark is going to be for talking about blood and why blood needs to flow. So we'll say to carry blood more easily, because there's more space now, it can carry more easily. Carry blood more easily to the heart muscle. Right, that's your second mark. And the third mark is for saying where glucose and oxygen can be delivered to cells for respiration. You'll get a mark for talking about glucose and oxygen, you'll get a mark for talking about respiration, and then obviously a mark for either of those, for both of those. So let's just link that back to the actual question. It says a heart attack is caused when the heart muscle cannot respire. So in your answer you're going to need to talk about respiration. Yeah. So how does it prevent a heart attack? Well, it prevents a heart attack by allowing the heart muscle to respire. Yeah. For respiration you need glucose and oxygen, and the blood is transporting them. The coronary artery is kept open by the stent to allow blood to flow and the glucose and oxygen to be delivered for respiration. Okay, moving on. To E. There's a lot of data in this question. I'm going to come back to that shortly. Now, here there are quite a few things you can say. I think the two ones to go for are the most obvious, which would be exercise is going to help prevent coronary heart disease, and also not smoking, drinking. You could also say not eating too much fat or sugar, because it is those fatty deposits that are blocking the coronary arteries. Okay, now we need to look at the data to answer this question. It says people in country B are more likely to die from coronary heart disease than people in country E. If we look up at the graph, here's country B. The number of coronary heart disease deaths is shown on the white bar here. So this is for country B. Once you compare country B with country E, here's the white bar for country E. Now, you could read this data from the graph, but actually it's shown to you in a table. Here are the number of coronary heart deaths for country B, 250. Here they are for country E, so we've got 250, 125. Doesn't require much thought to work out that B is 2 times E. So, how many more times likely? It would be 2 times more likely. So twice times 2. Either is fine. Okay. Question 3. Obesity can lead to heart disease. Other than heart disease, 2 conditions which are linked to obesity. So we're actually looking for 2 other conditions now. If you eat too much sugar and fat, you're likely to get obese. Another condition which is linked to that would be diabetes, type 2 diabetes. Because if you have too much sugar in your diet, it essentially gets to a point where your body doesn't react to the insulin being released from the pancreas, and that's a big problem because you can't control your blood sugar levels. Diabetes is linked to obesity. Also going to put respiratory disease here. Respiratory disease is a disease linked to your breathing, and if you're obese it can become more difficult to breathe, and obviously that's not very good for you. One of the many reasons you need to watch your weight. Okay, 3b part 1. So if we just have a look at this graph first, you'll see that the number of deaths from heart disease is pretty much non-existent in males and females before the age of 35. From 35 it starts to increase, but it increases a lot faster for males than it does for females. In general, we'd say males have a lot higher risk, a much higher risk of death from heart disease, whereas females, although it is high around here, generally speaking it is less than males. So it wants 2 differences between the patterns for men and women. The first would be to say that men are more likely to die from heart disease. We can see that in the data. There are lots of deaths here, right? Very few deaths for women compared, and they're around equal at this stage, although women are a bit higher here. There's a longer period of time, a much longer period of time in which men could die from heart disease, so they are more likely in general. And I would also say men peak earlier. So the peak for women is here at age 85 to 90, whereas the peak here for men is around 75, and the peak is higher as well. So you could say peak earlier, we could say they peak higher as well. Either would be fine for a mark there, I think. 2 reasons for the difference. Now, the command word here is suggest. So you need to use your own knowledge here to come up with a reasonable reason why we have these differences that we've spoken about before, right? Men are more likely to die from heart disease. Why is that? So it could be any number of reasons, but something sensible would be to say maybe men suffer more from obesity. Because it's just a suggest, you don't necessarily need the data, but it's a sensible suggestion based on what we've seen here. You could say men smoke and drink more often. Again, we're not 100% sure about that, but it's a reasonable suggestion if we've got the data here. You could say that men are genetically more likely to get heart disease. It is the case that some diseases are more likely in men and some are more likely in women. It could just be the case that this is more likely in men. So a few reasonable points there. You get a mark for each of these. And then last question. So cholesterol is a type of fat found in the blood. We know that statins are used to reduce the amount of cholesterol in the blood. So if there's a lot of cholesterol in the blood, it could lead to those fatty deposits and possibly the kind of heart diseases we've been looking at so far. Now, there's a graph below here. There's a helpful hint which helps you work out what's going on in this graph. So A, B, C and D, they are different treatments. They are statins, and a person has had these different types of statins over the course of 8 years. Now, if you look at this graph, the arrow indicates the cholesterol in the blood. So when a person was taking statin A, the cholesterol was actually going up. So the statin really wasn't working very well, right? Then they started taking B and it started going up even more. So B is worse than A, but you wouldn't say A and B are very good at all. Then they started taking A and B together, and then the cholesterol level started to fall. So we'd say A and B are pretty good because they're causing it to fall, whereas so A and B together, they're taking a statin of A and a statin of B at the same time. Just taking A on its own, no good. Just taking B on its own, double no good, right, because it's going up even more there. They did that for a while, then they stopped and they started taking A and C, a new one, right? That's no good because the cholesterol started to rise again. Then they scrapped all of these. They took just D on its own and we saw a steady decrease there. D is doing the job of the statin and lowering the cholesterol level in the blood, and as you can see, that went for about 8 years. So how should we write this up? Okay, the hint says you can start by stating the most and least effective statin treatments, then the treatments which are in the middle. So it's a compare question. You want to say, okay, this one's good, this one's bad, similarities and differences, advantages and disadvantages. Okay, so the light in the room's just gone off. I'm just going to go and correct that. Okay, I'm back with you. So we would say here that the steepest line going down is A and B. So A and B together are the most effective treatment. You get a mark for saying that. A plus B is the most effective. Very good. Now, D is the second most effective, and we could say it's the most effective single treatment, because obviously A and B is two treatments together. Okay, now let's look at some which aren't effective at all. We could say A and B are not effective because that's actually raising the cholesterol level. A is not effective. B is even worse. And then what other combinations have we got here? We've got A and C. A plus C is also not effective because that's causing concentration to go up. Okay, get a mark for each of those points. That would give you 4 marks out of 30. Okay, how long has that taken me to do? Let's go and have a look at my start and end time. So the time now is about 5:45. It's taken me about, what's that, 20 minutes or so. A little bit more, 22 minutes. Okay, thank you very much.